Okay, the presentation I'm making today is called Using the %Scan function. It's been very helpful to me over the last couple of years and very useful, and hopefully be useful to you listening to my presentation. Okay, the outline is how do we use the scan macro function? And we have a couple applications I've listed here, and these are actual applications I've encountered in my industry, in my business. So we're going to look first at how to uppercase all SAS data variable names automatically. Kind of a strange request, but you'll see why it's useful. And then we'll look at using the SGScatter procedure in SAS, which a lot of times will load up all plots into one big plot. But can we sort of split up the number of plots into a workable number of SGScatter plots? And like with SAS, there's always more than one way to fix a problem. Okay, so what is the scan function? The scan function is a macro function that pulls out parts of a macro variable that has values in that macro variable that are delimited by special characters. And the special characters from the SAS support documentation shows it's typically a blank, but there may be some other delimiters. And typically in this presentation, I'll just use blank as my delimiter. Okay. So the scan function has 2 to 4 arguments. The first argument is the macro variable that you will parse. So we're going to have a macro variable which has a lot of values separated by the delimiters. The second argument is the part number. 1 will be the first part, 2 will be the second part, and so forth. The third argument defines the delimiter. I guess the 2 to 4 means that the default delimiter will be the space or the blank. And the fourth argument is optional. It may not be available in earlier versions of SAS 9.4, but I was doing some reading on it, and it's a special modifier to handle special delimiter codes to handle more specific needs. The one example I remembered is that typically we go from the left to the right, but you can reverse it going from the right to the left of those parts in that macro you're parsing out of. Okay, we're going to look at the first application. So this is an application that actually some colleague, well, a good friend of mine, sent out an email to a lot of the SAS users that says, is there any way to automatically convert variable names to all uppercase, either with a macro or some automatic way of doing it? At the time it seemed a bit strange, but it made sense if you have many variables in a data set with mixed cases, because proc contents typically will sort the uppercase variable names first, and then we'll go into the lowercase variables. So if you're looking for a variable, you know if it's uppercase or not, you're scrolling over maybe many hundreds of lines of output. All right, so let's start testing our code. And normally I just create some test data, which is pretty simple here. I'm creating 5 variables, AAA2, BBB4, CC4, DD2, and XYZ44. And we output the data. So there's only going to be one observation, but there are 5 variables. 1, 2, 3, 4, 5. Okay, now I created a macro. And normally I store macros in catalogs or autocalls, but that's where you don't have to put it in every code, but we're not going to describe that setup here. So the macro starts with the macro name, which is called upcase V. And it has 2 parameters being passed in, a lib for the lib name and ds for the dataset name. So now what I do is I do a proc contents, data equals lib 2 dots, ampersand ds dot. Why do I have 2 dots? Because the dot always indicates that's the end of the macro variable. So if I just included lib dot ampersand ds, it wouldn't work. And then I have an output output the information, the metadata, to a data set called CNTS. And typically I would have no print because I don't want to see what the problem is. But what I did is actually commented this out so you could see how the proc contents will sort the variables. Okay, so this is actually looking at the contents, and we see that the AA comes first, and CC, but the BBs should be between the AA and the CC. It's embarrassing variable names. And so we want to try to fix it so it's going to be all uppercase and it'll be alphabetized in the proper order. Okay, here's some few questions here. The test data has one observation of 5 variables, but the CNTS data set has 5 observations, the variable names, as you see down on the lower part of the slide, and 41 other variables depending on the version of SAS you're using. So the variables in the contents data, there's an appendix in this presentation for a list of the 41 variables that I was able to access from when I developed this program. Now, the other thing I'm also looking at is the type. The type variable, what happened? The type variable is 1 for numeric and 2 for character. Because sometimes you just want to process a numeric variable, sometimes you want to process the character, or a mix of both. Okay, let's now create the macro that we're going to parse, which has a lot of values. It'll be all the 5 names, and then we're going to parse each one at a time. This is one of my favorite SQL functions, the into function, where it creates a macro variable. So I'm selecting name, into, the macro variable is VARS, and it's separated by the delimiter of blank quotes, quote, blank quote. And I'm pulling that from CNTS. And I do quit. And just to verify that we get the right information in the log, I'm putting a put statement to put vars equals to vars. And you see they're named in the same order that the contents are named. Okay, now it gets kind of loopy a bit because there are a lot of additional do loops. I know there's 5 variables in the data set, but I want this to be automatic for every time I'm using this. So I'm starting my increment by 1. So let I equals 1. Okay, so then I'm using the proc data sets, which is a very useful way to access some of the metadata. And you can modify the metadata without actually touching the data. So the library is lib, the ampersand variable here. There's the no list, and I'm modifying the ampersand ds, which is the data set I created, test. And then I'm using the macro function, but I want to do this until the scan of the macro function is going to end up just being blank. And then I want to create a new variable called var, which is a single variable we're pulling out each time we're processing using the scan function. So the var is going to be the scan var from the macro variable vars, and we're setting it up initially as being the first variable, and the str parentheses is a way of saying it's going to be a blank statement after that. Oh, that's the delimiter here. So now I'm going to say, let's create a new macro variable called ren, where ren is going to be the uppercase of the ampersand var. So now if the variable ampersand var is not equal to ampersand ren, then we're going to do this with a do loop, which to rename the var to be ren. And then we end that particular loop. But then we have to make sure we're going to increment the increment of which value we're pulling. So we're saying let I is to use the eval function ampersand I plus 1. So the next time we'll pull the 2, then 3, and 4, and then 5. And then we'll see what the proc contents turns out to be and run the macro at the bottom there. And look at that. It's perfect. AA, BB, CC, DD, and XYZ. Okay. This code didn't work too, so maybe I could skip over we're in the middle loop, but I was going to rename all vars to uppercase, but proc datasets gave me an error, and it said AA2 is already capitalized, and it just aborted the program. So don't use this program. The second application, why is it blurry like this? Oh, here we go. The second application, let me just go skip it. So let's say we're going to work with SGScatter. And there's probably more than one ways of doing what I'm doing here, probably with proc template. But I like playing with the scan function. So just a simple example. Let's say you want to build a regression model. You have a good number of independent variables that you want to see how they predict the dependent variable using SGScatter. You're still going to be building a multiple linear regression, but you're just looking to see if the variables make sense or if there's issues with the variable not being linear. So you may want to try some parametric splines, which I'm not covering in this presentation. You don't want to see all the plots in a single run of SGScatter, because SGScatter will generate all the plots you specify. But I was looking at the code, the syntax, and it has a rows and a columns option. So I said, why don't we just try that? So here I have a code. I'm using the SAS help data sets. Now, if you've never heard of SAS help, it's available in all SAS applications, and it has a lot of interesting databases to play around with data and test your code. And the data set I'm using here is the baseball data sets. And the DV, which is the dependent variable, is CRAT bat, which is the career times at bat. So that'll be the y-axis, and the x-axis is going to be each independent variable. So what I did in the previous example, I did the proc contents with the no print output run. Now here I'm a little modifying the SQL into a bit, where I want to take the names, select name into vars, separated by a space from CNTS, where type equals 1, because you don't want to use this for character variables, and the name is not equal to the dependent variable. You could use it, but it'll be a straight line going diagonally up. Now let's try just saying proc SGScatter, plot all these variables, and I'm putting down there rows equals 2 and columns equals 3. So I figure I'm going to get 6 plots on a single SGScatter. Let's see what happens. Oops. I got 3 columns, but not 2 rows. So I'm thinking, how do I split this up? What if I wanted like 4 plots on each SGScatter? Okay. So here I'm adding n plots, how many plots I want on each scatter plot. Let rows equals 2. So that by default, it would be 2 columns and 2 rows. And replicating what I had on the previous page. Now this may be a bit more loopy because there's a lot of loops, and you have to try to focus on what you're actually doing. But it looks like what we did in the last time. We start with incremental 1, and then we do until we go through all the variables that we're pulling off the initial ampersand vars macro variable, and we're pulling each one at a time. And this next macro do loop plot stream is going from 1 to n plots, which is 4. So I want the next macro variable to be plot 1 plus 2 plus 3 plus 4, but now it's going to tell me which variable I'm pulling off based on my ampersand I. So the first time we'll do this, it'll be 1, 2, 3, 4. The second time we'll do it will be plot 5, 6, 7, 8, and so forth. And here we're also incrementing the I loop, I variable, with an eval term at this point. Because once we get the 4 plots here, we're going to increment one more time, and then when we go through the loop, the do until loop, it'll process all the variables, multiples of 4. Okay. So now let's do proc SGScatter. Data is equal to the the library name and the dataset name. And now we can say a plot, ampersand dv, which is our y-axis, the dependent variable, multiply by, within parentheses, to do a plot stream from 1 to 4. So now it's going to output, the first time we plot variable 1, variable 2, variable 3, variable 4. Next time it's going to 5, 6, 7, 8, 9. Now, some people may ask, why are you missing semicolons? And you don't want a semicolon after the plot underscore stream. You want it at the end of the plot statement. And it looks pretty fuzzy, but it does work. And you don't want to include this other ampersand increment eval. And you got to be careful. Sometimes you have to make sure you have that eval always increasing. I once submitted a code that I forgot to include that eval function, and it was plotting or looking at the same value each time. So, hey, look at this. It works. I got 4 plots per page. So if you go back to the previous plot, there were 17 plots. I'm sort of worried that maybe the last, plot won't show up because it's not divisible by 4. Here we have some variables we're looking at. Oh, this looks pretty good. So if a baseball player has a lot of careers of hitting the ball, he's going to be number of careers time at bat. Income the person's making may be related to how many times he's going to be at the bat. It's just playing around with data. I should have probably used some different dependent variable like income. Now we look at the next 4 plots are up to 8 plots now. These are not very predictive of the dependent variable. And also I'm using a Loess function, which sort of is a scatter plot smoothing function to try to see what's the general trend. That's the red line. And a lot of things you could do. You can add credit limits, or not. Limits on the expected mean result. This one is the 17th one. It's still printed it out, which I'm great. I didn't lose a plot, and it's pretty flat. Oh, okay, here we go. We got the appendix, and this is showing 41 variables that you could get out of contents with a no print and output to a data set. So you could get some more information on the metadata of your data set. But typically I would use for these applications is the name and the type. The type tells me whether it's numeric or character, and the name is the name of the variable. Now you don't have to use the SQLint to create your macro list. You can create it with a let statement, and even with returns, there are going to be blanks until the last variable is pulled out. And now some disclaimers. SAS is a trademark of the SAS Institute. Other brands and product names used in this presentation are trademarks of their respective companies. I don't think I used other companies. The contents of this paper are the work of the author and do not necessarily represent the opinions, recommendations, or practices of any company that we have worked for or are currently working for. I use we because sometimes a lot of colleagues or friends are also making a presentation with me. And there's no warranty on the code illustrated in this presentation, because every now and then I'll make a typo, and I don't want to be blamed by it. You can expect typos. And there's some nice references we can look at. The first one is, I got to update it, but it was one I made at the Philadelphia SAS User Group meeting in 2018. And I think that first example was in that presentation. Now, Art Carpenter is a great guy of learning a lot about macros. I forgot to include his SAS Press book in here, but if it's still available, you should get it. If you're still trying to learn the new SG procedures, which I call the super graphics, plot, panel, or SG scatter, you could start with Susan Slaughter and Laura Delawecchi presentation at I think SAS Global 2012. There was another interesting paper at 2010. And also Michael Reitveld had a great paper on using proc data sets, and that was presented at SAS Global 2010. So hopefully you enjoyed the presentation, and hopefully I didn't make it too dizzy trying to go through all these loops.